Welcome. This is my first video all by myself. Miss Burkhart is not here right now, so I'm doing it all by my lonesome. Sorry guys. So the title today is about electric charges and static electricity. If you're in regular science, you need to grab the handout. The handout looks like this. It's two-sided and it has just like stuff on it, and it says, it looks like a foldable. Then if you're a challenge science kid, you need a blank piece of paper. And I might have some color paper for you. If you're lucky, I'll find some. But if not, just a blank piece of white paper, and we are going to create yours. Whoa. Pretty cool stuff here. Okay. So here we go. Ready to rock and roll. You also need some scissors and some colors here too. So the first thing we need to talk about with electricity is how do we charge something. You might have heard of charges before, electric charges or something like that. You got to go back to 6th grade when they talked about atoms. Now here I kind of drew a really crazy little atom. You have your protons and neutrons, protons and neutrons in the middle in the nucleus, and you have electrons. Well, those electrons are hyperactive little kindergartners that go super crazy fast, like kindergartners on Red Bull or something. So when those electrons get lost, they get rubbed onto something, or they get hopped over from something else, you get a charge. So if an object gains or loses an electron, you get a charge. So if an object gains electrons, so more electrons hop onto you, electrons are negative, so the object gets a negative charge. If I lose electrons, I'm losing some of my negative forces, my negative little electrons. I become more positive. I kind of think of it like people. Sometimes there's negative people and positive people, and they can put their negativity onto you, or they could take some of your negativity. You're whining and complaining, and they could take some of your negativity, but they might become negative themselves. So electrons are the only ones that leave. Protons and neutrons can't leave. If that happens, it's like boom, atomic bomb. So they don't leave. Only the electrons leave, and when they leave, it becomes, you're losing some of your negativity, so it becomes positive. Now, if they're going to you, if the electrons are going on that object, it's going to get more negative because all the electrons are hopping on. However, this is the most important thing. We can't make these charges. We do not make electrons ever, ever, ever. We don't make something negative. We don't make something positive. We just transfer charges. Everything that ever is to be created has already been created. So we cannot create or destroy charges. They're already there. This is called the law of conservation of matter and energy. Everything that was created has already been created, including all the electrons and protons in the whole wide universe. So think about this with positive objects. If an object loses an electron, it becomes positive. And usually it's going to lose thousands of electrons at a time. It's positive because it has more protons. So look at this little rod. It's a little piece of plastic. It's kind of like a comb. When you comb your hair so much, your hair gets all frizzy. That's because you're putting a charge into your hair. So look at this little comb thingy here. See all the plus marks? There really is way more positive charges in that comb and only 2 negative charges. So that comb, it has a positive charge. That's how we're going to represent it in our classroom with our assessments. You will see little plus signs and negative signs on your assessments. So what you're doing with this foldable, this is the first time you had to write down. So if you're in regular science, you probably should have folded this piece of paper. You fold it on the dotted lines. If you're in challenge science, just fold a piece of paper like this. And then, it doesn't matter when you cut, guys. You just make a couple cuts. Regular science, you just make it on the dark, dark lines. So now I have flippity flaps. Where it says positive, that's where I'm going to write my notes. Definition, notes. It goes right here. Does that make sense? I open the flap, and I'm going to write when an object loses an electron. And then on my picture, I could draw this little picture of that comb with all the plus marks, but I also have drawn a balloon. Because I think of balloons a lot. We can't use them in school because there's some latex allergies. But balloons a lot, when you rub a balloon on your head, it gets charged up really, really well. Rubber is a great material for that. So I have all my electrons leaving because that's the only thing that can leave and come. And I have 1, 2, 3, 4, 5, 6 positive signs and 3 negative signs. So I know my balloon has a positive charge. So go ahead and pause the video and do that. Welcome back. Now we're on this center part called neutral. When I think about neutral, if you are neutral to something, that means you really have no opinion about it. So if I'm neutral about school uniforms, I don't care if you do school uniforms or not. I have no opinion. So with charges, neutral means kind of like even. You have the same amount or equal amount of positive and negative charges. So again, that definition goes right here where it says definition notes. And for your drawing, you could draw this like cotton piece, and this is like a piece of amber. It's like a special rock. It's what they used in Jurassic Park where the mosquito was stuck in. But you know there's only 3 positive and 3 negative. So we know this has no charge. I drew a balloon that had 4 positives and 4 negatives. No, 5 positives, 5 negatives. I can't count. Shh, don't tell anybody. Sorry, little secret. So that's a neutral object. It has no charge. Right now my hair is pretty neutral. It's not like standing up crazy. When your hair gets all staticky and goes like this, then you know you have some sort of charge. But my hair is like kind of normal today-ish. So I'm pretty much a neutral charge. That's all. I'm down with that. And the cool thing about neutral things, I want you to add this in the definition section, is it doesn't attract or repel things. It won't attract or repel other objects. Because you can attract stuff with static electricity, and you're going to play with that later. Like with like some of your mini explorations. Okay, let's talk about the negative nillies, okay? A negative object, and this is going on the bottom flap right here. A negative object, as you can guess, gains electrons. See my E with a negative sign? That means electrons. I'm just showing you some shorthand. This is universal for electrons. E, because E is for electron, and negative because it's negative. And it's negative because it has more electrons than protons. So if I rub some electrons from my hair to a balloon, I'm giving that balloon more electrons. So that balloon becomes negative while my hair loses electrons, so it will become positive. So here you'll see a cloth and a rod. In this picture, the little blue guys represent electrons. So you can see on this cloth, there's 1, 2, 3 protons. And the protons are really big here because protons really are bigger than electrons. And you got 1, 2, 3, 4, 5, 6, 7 electrons on this cloth. So that cloth is going to be staticky and really clingy. Kind of like when your mom or dad forgets to put a dryer sheet when they do your laundry and that sock sticks inside your pants. I've had that happen to a kid before. Like he was walking around and all of a sudden it wasn't a sock, so it was kind of his underoos. Like they fell out of his pants because initially his clothes had a charge and they were attracted to each other, and eventually that charge went away and it fell out of his pants. That was kind of funny and embarrassing for him. Okay, there's 3 ways to induce a charge. 3 ways to charge it. I'm trying to be funny here. Get it? Credit card charge, money. So there's 3 ways to charge an object. And those 3 ways for regular science kids are written right here. Friction, induction, conduction. So now we're on this side. We talked about the 3 types of charges, and now we're going to talk about the 3 ways to get one of those charges. And I expect you to kind of know all 3. Regular challenge kids, just write friction, conduction, induction. So pause your video, set up your little foldable. Okay, friction. Friction is like something you've heard of before. And friction occurs when 2 things rub against each other. So sometimes when you rub a balloon against your head, you're actually transferring electrons due to the rubbing. So I underlined the word friction here, and I highlighted the word rubbing because that's really important. So in your tab, right here, write the definition. Transfer electrons from one uncharged object to another by rubbing. And maybe highlight the word rubbing or underline it, put little stars around it so it sticks out. Friction, rubbing. And then look at our lady. I guess she's blind. That's why she's wearing sunglasses. I don't know. But her hair and the balloon are neutral right now. They totally are. Then look. She rubs, without her arms, magically, she rubs that balloon across her head. And you can see a lot more electrons are leaving her hair and going to the balloon. So the balloon becomes negative and her hair becomes positive. Since all her hairs are positive, they start repelling each other. Because like charges repel, just like magnets. They push against, like poles repel. Plus, 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 all repel each other. So that's what makes your hair stand up. When it's staticky, they're all like the same charge, and they're just like, hey, get away from me, I'm positive. Oh, I'm positive too, get away from me. So that's what's going on here. Same thing at Magic House. Your hair stands up on that little ball thing because they're all the same charge. So let's look at the middle one. This is a new word. This is called induction. Induction. This is the weirdest one to understand. So this is the movement of electrons that is caused by the electric field of a second object. So let's take our little pen here and let's really go around and circle that electric field. And then you see in green how I wrote no touching required. So the electric field, because just like there's a magnetic field around my magnets, there's a field around here that will attract a something with iron, just a field. There's a field around many objects with charges, and that's called an electric field. It looks just like the magnetic field, like the bubbly looking. And that field can transfer the electrons to you. So look at this. This kid is getting zapped before he touches the doorknob. And that happens a lot during the winter months. You shuffle your feet across the carpet, and right before you hit the light switch or right before you hit the doorknob, you get zapped. It's crazy. So for my picture for the induction, I just don't laugh at me. I tried to draw a doorknob and me getting zapped ahead of time. For my friction, I forgot to show you that, I just did the balloon thing. So if you need to pause the video and copy, you can. Both regular and challenge should be drawing pictures. So here's my induction. So induction is getting a charge without touching through the field. Here's the last one. It's called conduction. Conduction. So conduction occurs when electrons are transferred from one object to another by direct, look at this, contact. So we have conduction has direct contact. Put those two together. If I'm contacting something, I'm literally touching it. I'm contacting it. So look at the girl. She has the Van de Graaff ball. That's the thing at the Magic House, which makes your hair stands up. She is actually touching it, and her hair is standing up. So she is transferring charges to her hair, and then say her hair is all becoming negative here, and it's like, ooh, I'm negative, get away from me. Ooh, I'm negative, get away from me. Ooh, I'm repelling you too. All these electrons are coming up her arm into her hair, and they're all repelling because they're like charges. So she's contacting it, and she's through conduction, she's getting charged. So static electricity itself is just the buildup of these charges. There's no room in this foldable. This foldable should be filled out. Oh, I forgot to show you my picture for conduction. I just drew the Van de Graaff, the best to my ability. That's the best I could do. So underneath, you'll glue this in your notebook, and then on the next page, I do want you to add the word static electricity. It's just the buildup of charges. You're just gaining and gaining and gaining and gaining all these charges. That's static electricity. It's different when you let those charges go. So this is when you shuffle your feet across the carpet, or in our plastic chairs, you rub your tush in that chair, and you get all charged up. When you let that charge go, when you actually touch somebody and zap them, that's called discharge. So static discharge is when a negative object and a positive object are brought together and electrons transfer until they both become the same. So if this was positive, if the balloon was positive and the guy was negative, he would transfer electrons to the balloon until they both had the same amount of electrons, because only electrons can move. The word discharge, I think of it like a hospital. If you were discharged from the hospital, you were let go. You probably heard of your parents being discharged from a hospital, or maybe you were discharged from a hospital. So you were let go from the hospital. So with electrons, they're let go from the object that's charged. And you'll experience this when you get to do the Van de Graaff. When you get to do the Van de Graaff, I'm going to ask you to discharge it. That's that little ball thingy. And I'm going to have you tap it with metal. That way you're no longer holding a charge, or it's no longer holding a charge. Because that, when it discharges, it hurts. It's that zap that you get. Most people call this the static electricity. But the static electricity is the buildup. The discharge is actually the zap. So most of the world calls it the wrong name. Go figure. Okay, a big example of static discharge is lightning. Lightning is not this scary thing. It's not coming from Zeus. It is because there's an unbalance of charges in the air. So look at these electrons here. There's so many in this lower cloud, and it's transferring some to this positive cloud up here. The clouds get charged because of friction. They're rubbing and rubbing and rubbing and rubbing against each other as there's a storm of brewing, and the clouds are moving. So the electrons are just balancing each other out. These electrons are going up here to balance out their charges. Sometimes electrons go down to the ground to balance out the ground. And if you look on this side, the electrons are all on the ground. They have to go up to the cloud because lightning can go both ways and go from the cloud down to the earth or from the earth to the cloud. It depends where is the negativity. Is the negative that moves up or the negative moves down? The electrons move. That's all lightning is. It's little bitty electrons saying, wee, I need to go up here. Let's go. It takes so much energy to move these electrons. You see big lightning and you hear the big thunder. That's what you're seeing. It's just electrons moving. So next time you see lightning, say, hey mom, hey pops, look, electrons are moving. And they'll think you're so smart, they'll take you out for ice cream. I promise. Okay, kiddos, that is it with static electricity. You have a few activities that are going to help you understand this totally, hopefully. But if you have any questions, come see me or Mrs. Burkhart. Have a great day.